Hello everyone. In this video we will complete all the restrictions or the constraints for the air traffic flow management optimization model. In this case, these are complementary restrictions. Um, the first one has to do with the pair of flights that are continued, right? So in this case, the binary decision variables of a flight F, right, at its origin, right, origin of F and different time instance, minus the binary decision variables of a flight F prima for the destination of that flight F prima, time minus SF, and SF is a parameter which has to do with the turnaround time. This must be lower or equal than 0. And this applies for all pair of flights F prima, meaning that F prima is continued by F, right? So we will have something like this is an airport K, this is F prima, and this is F. So the destination, this is the destination of F prima is K, and the origin of F is also K, right? So we are kind of pivoting over or around the airport that is connecting the flight. So this applies for these pair of flights that belong to the set C, remember, of flights that are continued, at the time window for airport K, or sorry, node, in this case, yeah, it would be node J, and flight F, right? So we are interested in this time, right? The time that I allowed to my aircraft F to depart. Now, what else? So then, this is my first equation. The second equation is omega of a given sector J, or node J, okay, at t minus 1 for a given flight, minus omega of the same sector of node time t should be lower or equal than 0, right? And this applies for all flights, right? All sectors belonging to the set of sectors the flight F is overflying, and all times, right, for allowed for the sector J and flight F. This is capital T, sorry. And this is basically, this is modeling the by condition for the binary decision variables, right? If I have something like this, imagine I have something like this, omega, right, imagine omega of, say, this is omega for a node J, F, T, okay? Omega J at time instant, say this is 10, this is 9, this is 8, okay? At time instant, or say 9, is equal to 0. But at time instant 8 is equal to 1. So omega J 8 F minus omega J 9 F, this should be lower or equal than 0. But it turns out that in this case, this is 1 and this is 0. So I am violating the constraint. So this can never happen. So this constraint is ensuring that once I jump, I stay. And that's the idea, okay? It is ensuring that my binary decision variables actually follow a step shape, and they don't do return back to 0. which again would make the model to not to be compliant. My third equation, this is probably the easiest, is saying that the binary decision variables for flights, for all the sectors and for all the times belong to are binaries, right? Either 0 or 1 for all flights, for all sectors, and for all times, as in the previous cases, right? As for the turnaround or the connectivity equation, I leave it to you, an open exercise to you, to actually fulfill or show or demonstrate that this equation is fulfilled and it makes sense and is consistent. And in the end, this equation is going to tell you, okay, imagine we have a turnaround time of 4 units of time, and you cannot see it, of 4 units of time to do the turnaround. And aircraft F' is arriving, say, right? So the arrival time for F' is equal to 5. And again, you cannot see it now. So this equation is going to tell you that the departure, the real departure time, regardless of what the scheduled departure time is, the real departure time of flight F can be only 5 plus 4, 9. 9 or later, right? You cannot depart at time 8, 7, 6 in this particular example. You must depart at time 9 or later. This is what this equation is telling you, plus the binary or the step character of my binary decision variables, plus the fact that they are binary. These three are the complementary restrictions that somehow complete our model. So thanks very much for your attention.